Welcome back to theCUBE coverage here live on the ground in Washington DC for the AWS Summit 2026. It is our last two guests of the day, but we are truly saving one of the really feel-good stories of 2026 so far for last. We bring on these next two. Joining me now is Josh Perrius from Booz Allen and Greg Clifton from Intel to talk about Artemis. What's not to love about that? Welcome, folks.
Yeah, thank you.
Thank you.
Thanks for having us.
Appreciate it.
So, when we think about these missions and the news around Artemis, and it was so exciting, I watched it on Instagram, I don't know about you, what a lot of folks don't realize is it takes a lot to do this, right? But it's not just a space mission, it's a data mission, it's a hardware mission, it's a meeting of many minds.
Right.
Talk to me, maybe I'll start with you, Josh, about how this partnership works underneath the hood. What do people not realize?
Sure. Yeah. The space in general is hard. And people in the space community love to say that, right? And but this is a particularly complex mission. We have not been out beyond really LEO with or low Earth orbit with humans since the 60s when we did, and the early 70s with the original Apollo program. So, there's thousands of calculations that have to be done to kind of prove out in simulations to make sure that these paths are going to work for taking the Artemis out past the moon and back, and so that's a huge amount of computation that has to get done, and it has to be done over and over again to make sure it's right. So we've worked to take that capability, which was running in on-prem servers at a government facility with NASA, and re-architected it to put it into the cloud on AWS and running on Intel chips. And so it's been, that's kind of how it came together. We're the software and they're the hardware, and getting that to speed up that whole process so that we could do that better and faster and in a more reliable way.
Intel, I mean, what a company. You guys have been on quite the journey. I joked off screen, I wish I bought that stock, I tell you that much. Talk about, you mentioned the original Apollo mission, right? Neil Armstrong didn't have a lot of the technology, a lot of the hardware, a lot of the metal,
right.
The visualization that we have now. Talk about what's been evolving from the perspective of hardware, space tech. And I'm also interested to ask, I'm going to ask this next, why did it take so many years to do this again? But let's start with the hardware.
Yeah, I think on the hardware side, Moore's Law is still alive, and I think we're even moving faster than that. So, as Josh said, the math to do this and to do that trajectory analysis and do it in real time takes high-end compute capability. But also I think the beauty of this working with AWS was the ability to burst beyond that on-prem environment to get that capacity on demand. That was for that trip. I think the cool thing too is what it's going to take for the next journey to actually land a human on the moon is going to take even more compute power. So we're actively working that now, looking at the latest technology, and it really, the technology matters, right? As you move from an older generation to a new generation, you get orders of magnitude better performance, particularly from an AI perspective, which I think you guys are using AI in a tremendous way to plan this journey and what we're trying to do. So yeah, we're always trying to push the envelope, and we're trying to push it with technology that's designed, engineered, and manufactured here in the US.
So you both of these companies have had a long-standing relationship with NASA.
Right.
Back when NASA was the only show in town, really, right, from the perspective of space tech has gotten very popular, very excitable very quickly. We see that. I mentioned to you that off camera, that I talked to a lot of entrepreneurs in the space, and they all kind of lead with the same thing, which is that, yes, space is extremely innovative and radical from many ways, but the technology and the operating systems and all of the hardware and software that goes into it is often decades old. Talk about what's evolving, though. Talk about what those conversations look like as these external pressures enter the space too. And I'll start with you, Josh.
Sure. So we've been a big part of actually that modernization, especially on the ground and in the software world at Booz Allen. So both in NASA, but also in the broader Department of Defense and in the intelligence community as well. So there's a lot of those systems needed to modernize for many different mission reasons. I mean, but the biggest one, I would say, if we had to pick one thing driving the complexity, is really the reduction in cost around launch that has led to this proliferation of so many more satellites in space, which makes for much more complex constellations to be managed, but also so much more data coming down. And so when you put those two things together, it just really ramps up the computing, that's really needed from both an analysis perspective, a management, the algorithms that go into scheduling and sort of figuring out what these sensors are going to look at and when, all the sensors that are used to gather data around, even things like Artemis, where the main focus is a crewed human flight, right, to go do this thing, but it's covered in sensors, so there's tons and tons of data coming down that needs to be analyzed and understood and shared between different entities who are doing different parts of the mission. And
let's talk about the silicon for space, right? Because it has its own nuances, its own requirements, etc. It varies. That type of technical capability sits on different types of chips, right? It needs specific requirements. What's happening? Like, where is the innovation happening from the perspective of Intel? Yeah. What do we not see when we think about the metal?
Yeah, I think it's in a lot of areas. Even you talked about the commercialization, which is bringing costs down, but it's also moving innovation forward. It's the same thing we've seen in any device, whether it was the Internet of Things world, other spaces where the capital that gets put in and the speed drives that innovation. I think what we're doing is try to bring state-of-the-art capabilities to that environment, whether it's on the ground or in space. We're working with partners to enable that so that they can move fast and, again, use the latest capability rather than, we all heard the stories about the space shuttles had less compute than an iPhone. That's changed dramatically, right? There's some significant compute capability going on these devices up in space and in the ground.
So we hear a lot about AI on the edge. It's having a unique moment, you could say. I don't think anyone knew what that meant 2 years ago. Mm-hmm. Now it's like a big billion, multi-billion-dollar bet. There's nothing more on the edge than the moon, right? Like, I mean, it's hard to imagine how far edge you could go. But from the perspective of, what's required, like we think about things like lower compute, like power, like all of those things. How does that kind of change from the perspective of the innovation cycle, both from a software inference perspective and from a hardware perspective? Like, what makes the build and the innovation unique?
I mean, I'll answer from our perspective. One of the things we're doing is we're building a system on a chip. So we're putting CPUs, GPUs, and NPU, a neural processing unit, all on the same device. So now you can have a multiple capability. I can run a mission thread on the CPU, I can do inference on the GPU, and I can do a long-standing AI run on the NPU. So trying to give that heterogeneous architecture flexibility so you can do lots of different workloads on that one compute device.
And from a software perspective, right? Because again, it's as remote as you can possibly imagine.
Right.
How do you think about that in terms of the future, like from an innovation perspective? Like, so much is happening so quick. There's some phenomenal innovations. What are most relevant to the space world?
Yeah, well, I think what probably a lot of people didn't know before is that satellites traditionally and the things we put into space were not that smart because of those constraints around swap, size, weight, and power, and some of the challenges around cooling, those things that you barely had a sensor up there that put data on the ground, and a lot of the smarts would happen in the software that was written on the ground. But as the missions have gotten more complex, and you have and you're putting then actual humans and things up there, and not just satellites, that really moves the need to put that compute closer to the edge. But also the size and because of the innovations we talked about around launch and stuff like that, and the ability to put more and more up is giving you the ability to put a more and more robust compute set at the edge. And so that's what's exciting is, so there's things we have to do around the software around making sure it can run in smaller environments, and Booz Allen has done that. We tailored a large language model to run on the International Space Station, to get it small enough to kind of fit on the compute there. We're doing space domain awareness type algorithms that can run on camera sets on small sats and things like that. But very excited about the lunar mission is that there's going to be actually a lot of really good compute there. But the challenges are going to be a lot around latency and and the ability to kind of move data back and forth in the communication paths. So trying to figure out all that architecture is really exciting, and figuring out what are the constantly working with the manufacturers and hardware partners on what exactly is going to be available at the edge, so that we can tune and customize the software to work best in that environment.
Yeah. And I think you're seeing that big time. Even it started on AI PCs, where it's developed from the ground up to operate disconnected. And so that technology that started out here and the ISV ecosystem that built it is moving into edge, into robotics and drones, and now into other harsher environments like space.
Let's talk about the partnerships for a second, because you mentioned that there's a lot of conversations happening at a hardware software level. This is like a huge multifaceted path to innovation, right? But at the end of the day, you both have been in business with NASA for a long time. Space is a competitive space. There's a lot of entrepreneurs with a lot of promise, but you guys are steady, reliable, long-term innovators. How do you think about that from the perspective of this entire ecosystem we're in right now and the competitive forces at play?
Well, I mean, I think from our perspective, we try not to rest on our laurels, right? We have this long history, over 70 years with NASA and in the broader space community, but the way you stay there is you have to keep changing for the mission, right? Adapt to what new technology is out there, and that's why the partnerships are really important to us, because we think we're smart and we like to come up with great ideas, but it's always better when you have more people contributing. And so, a great example was in the Artemis mission. So we were using, Xeon processors from Intel that were specific for high performance computing, and it worked really well, and we were able to see this huge improvement in performance. But as we look, to the future missions for Artemis, like we talked about, they're going to be even more and more complex. So we're partnering on how to tune and adjust those algorithms to be even more performant, take better advantage of the capabilities of the new chipsets coming, and kind of looking forward with that. And that we wouldn't be able to do without that partnership. Right. We wouldn't see those things ahead of time, wouldn't be able to do that. And so that's a win-win for both our companies, because we're both learning and working on a better outcome, but it's a huge win on the mission for the government, because they're getting a much better solution.
And we think about the communication rhythm, right? The building process, the co-build, the co-innovation that needs to happen. Time is of the essence here, right? So the cadence, I'm sure, is much shorter than it was before, where folks built in silos, put them together and hoped for the best, right? No, that's not what happens now. Talk about how this relationship iterates, even, like how you guys innovate together as a partner network with NASA and with many other partners.
Yeah, I think it's a lot of testing, trial, error, but that's much faster now. Even you do your DevOps up in the cloud, you don't have to stand up your own environment to do that anymore. And even on the last question, I think you look at space, it's just another environment, another challenge, right? We've done that over the years when we first went out to the edge, or when we first developed cloud, or now in AI. It's just another interesting problem to go after and see how can we connect hardware, software, networking to solve a unique, in this case, size, weight, power, environmental challenge.
Well, it's certainly a great story. What other great stories are on the horizon, folks? Are there any big bets that you both have on the calendar, on the roadmap for the rest of 2026, 2027? Something we could hope to be talking about a year from now. I'll start with you, Josh.
Well, yeah, I mean, I think the future Artemis missions are one. I mean, if you've seen what the NASA administrators talked about, they're rapidly changing. Even the plans that we thought we had in place a year or two ago are going to be greatly accelerated with many more Artemis missions coming. And so we're working really hard on making sure we're ready for all those. The Artemis 3 will be a low Earth orbit test, but then Artemis 4, again, back to the, actually testing, getting onto the moon again, and actually landing there. And so in the future missions like that. So there'll just be more and more complexity around that. We're continuing at Booz Allen to invest in space. We invested in the startups as well, to your point about all the entrepreneurs in that space. We're trying to find additional partners. We have long-term partners who are obviously huge multinational conglomerates that we work with, but we're also trying to find these little niche players as well to see who we can partner with. So there's new spacecraft providers who are bringing new compute into space that we're interested in. So we're working with them on the different sensors and missions that we can put onto their hardware as well.
Wow.
And I think for us, just edge in general, we're spending a lot of time in physical AI, robotics, we're working in healthcare, we're working in manufacturing. So it's going to be interesting with what we've done from a compute perspective. We're solving a lot of the size, weight, power challenges. As I mentioned, that multiple different workloads on one device. We're going to keep pushing the envelope. I think there's all kinds of problems that we can solve across lots of different mission spaces, whether it's government, industry, education. So.
Well, the world is certainly your oyster, or the moon. Yeah. Folks, thank you so much for joining us on theCUBE.
All right, thank you very much. It was great.
I'm Gemma Allen, and that is a wrap on day 2 here at the AWS Summit in Washington, DC. We had a phenomenal 2 days, talked to some great minds of industry, leaving with a lot of hope for what's ahead for this community and this company for 2026 to 2027. Thank you so much for watching.